Radar equation. Let's go over the radar equation. In this example, we have a radar located on a ship. The two key parameters that determine your ability to detect a target are the transmit power and aperture of the radar. The aperture refers to the size of the antenna, and the transmitted power is the energy output. The more power you have, and the larger your aperture, the better you'll be able to focus energy on a target and collect the reflected echo. When you transmit a pulse, it travels toward a target with a radar cross-section, denoted as sigma, at a certain distance from the radar. The question is, how much energy will you receive back, considering all these properties? First, you'll receive more energy if you increase the radar's transmitted power. There's a term for transmit power in the equation, along with another term for the gain of the transmitting antenna. The gain is expressed as 4 pi a by lambda square, which reflects the directivity of the antenna compared to an isotropic radiator. Then, there's a spreading factor because as the energy propagates, its density decreases as 1 by r square, and this must be accounted for. Throughout the process of transmitting, hitting the target, and receiving the signal, various losses occur. These inefficiencies are inherent to the radar system. For example, energy is lost when it travels from the transmitter to the antenna through waveguides, where some energy is converted to heat. Additionally, there's energy loss due to atmospheric attenuation and other factors. These losses must be considered when calculating the received energy. The larger the target's radar cross-section, the more power will be received, so this is another multiplying factor. Additionally, there's a second spreading factor of 1 by r square for the return signal, as the energy density of the reflected echo also decreases as it travels back to the radar. A larger antenna will better receive the returning energy, so there's another factor for antenna size. Finally, the longer you listen for the target, the more power you'll accumulate in your receiver. These are the main components that determine how much received energy you get. Thank you. Meet you in next video.